So this is section 1.3, applications of inequalities. So we just saw in linear inequalities in section 1.2 and how to solve them and represent the answer in two ways. So these inequalities are applicable also in solving real-world linear inequality problems, right? Profits, current ratios, and current liabilities, and so on. So we can apply this in finding how determining whether a production yields profit or a loss. We can also use it to find current ratios and current liabilities. So we recall that total profit is given by total revenue minus total cost. All right. So whenever this quantity is greater than 0, we say that the production sales has yielded a profit, or the company has realized a profit. Okay. In other words, if total revenue is greater than total cost, then there is a profit. And if total revenue minus total cost is less than 0, or total revenue is less than total cost, then there is a loss. The company has realized a loss. All right. A current ratio for a given product is defined by its current assets over its current liability. Okay, the current ratio of a given business, of a given business is defined by the ratio of its current assets and its current liability. So current ratio is basically current assets over current liabilities. So let's look at how we can apply this in solving a couple of problems. So this one says the Davis Company manufactures a product that has a unit selling price of 20 Rand and a unit cost of 15 Rand. If the fixed costs are 600,000, determine the least number of units that must be sold for the company to make a profit. The least number of units that must be sold for the company to make a profit. Okay. When we hear of least number talks of greater or equal to. So if I say X is greater or equal to 2, then 2 is the least number that X can take, all right? Because X can be 2 or anything greater than 2. So 2 is therefore the least number that X can take. So take note of the way inequalities are represented grammatically in English, all right? So sometimes you will see words like a maximum of, at least, at most, least number, highest number, and so on, all right? These are English representations of inequalities. Okay, so therefore, we are asked to determine the least number of units that must be sold for the company to. So let X be the least number of units, basically, all right? If X is the least number of units that must be sold for the company to make a profit, we know that for there to be a profit, okay, profit is equal to total revenue minus total cost. So for the company to make a profit, we want to find the least number or the value of X for which total revenue minus total cost is greater than 0. Okay, we want to solve this inequality for X. So what is my total revenue now? So we are told that the unit selling price is 20, and we know that revenue is price times quantity. All right, 20 Rand for each unit of the product, and we want to sell X units for us to make a profit. So Price per unit times total number of units gives me my total revenue minus total cost. Total cost is fixed cost plus variable cost. We know that fixed cost is 600,000, and we also know that variable cost is 15 for 1 unit. So for X units, the variable cost will be 15X, and all of this should be greater than 0. Okay, so if we solve this inequality for X, where we have already declared that X is the least number of units that are required to be sold for there to be a profit, then we would have answered the question. Okay, so this is typically a linear inequality where we can collect terms in X together and isolate X. So 20X minus 600,000 minus 15X is greater than 0. 20X minus 15X is 5X minus 600,000 is greater than 0. 5X is greater than 600,000. Divide both sides by 5. We have that our X is typically greater than 600,000 over 5, which is 12,000. Okay, so X is greater than 12,000. Okay, so therefore the least number of units should be 12,001 units. All right, because this is the very next number. So X greater than 12,000 tells me that X takes values from 12,001, 12,002, and so on and so forth. Okay, these are the values that are greater, strictly bigger than 12,000. The least of them is 12,001. So that's the least number of units that need to be produced for us to have a profit. Okay, let's look at the next one. The next one says that to produce 1 unit of a product, the company determines that the cost of material is 2 Rand 50 and the cost of labor is 4 Rand. The fixed cost is 5,000. If the cost to a wholesaler is 740 per unit, determine the least number of units that must be sold for the company to realize a profit. Okay, determine the least number of units that must be sold for the company to realize. Again, to realize a profit, total revenue must be greater than total cost. Okay, now this is the same thing as saying, so you can either use TR minus TC should be greater than 0, or you move TC to that side and get TR is greater than TC. These two are the same inequality, all right? You can use either of them to solve your profit inequality question. Okay, I think let me just quickly undo this. Okay. To solve your profit inequality question, you can just use any of them basically. That's this. Okay. So let's just go ahead. All right. So that's that. So total revenue must be greater than total cost. What's total revenue? Determine the least number of units. Again, we can let X be the least number of units, okay, that must be sold for there to be a profit. We can let X be that. So total revenue is price times quantity. So the company determines that the cost of material is $2.50 and the cost of labor is $4. The fixed cost is this. Now the cost to a wholesaler is actually the price, okay? Because that's how much the wholesaler buys it for. It's $7.40. So 740 times X is my total revenue, and this must be greater than total cost. Total cost is variable cost plus fixed cost. Now, variable cost is the sum of the cost of material and the cost of labor. These are all variable costs. So variable cost plus fixed cost. Fixed cost is 5,000 plus variable cost is $2.50 plus $4 X, all right? Because this is the variable cost to produce 1 unit. So for X units, we multiply that value by X. Then we have this linear equation in X that we can solve. So it's a 740 X is greater than 5,000 plus this is 650 X. We move the 650 to the side. We get 740X minus 650X is greater than 5,000. Okay, 740 minus 650 should be 0.99 if I'm not mistaken. All right, because we have 750 minus 650 should have been 1. All right, so it's 0.9. X is greater than 5,000 and X divide both sides by 0.9. Okay, let me just write this properly. I don't have my calculator here, so if it's not 0.9, you can quickly just calculate. Or let me just quickly do this. So it's 7.40 minus 6.50. Yeah, it's 0.9, correct? 0.9 over 0.9, so that we have our X to be greater than 5,000 divided by 0.9, which is 5,555. 0.9, please, not 0.5. 5,555.56, which we round to the nearest unit, right? So X is typically greater than 5,556 units, all right? So the least number of units that should be sold, X is actually equal to 5,557. Is the least number of units, okay? Because greater than 5,556 should be 5,557. Least number of units that should be sold for us for them to realize a profit. So this question is typically the same as the previous one. Now let's look at this third one. Okay, it's still the same, about the same thing, but this time around we are looking at the cost of 2 different ventures, all right? 2 different options. So a businesswoman wants to know the difference between cost of owning and leasing a car. She can lease a car for $420 per month on an annual basis. Under this plan, the cost per mile of oil and gas is 0.06. If she were to purchase the car instead, the fixed annual expense would be 4,700 and other costs will amount to 0.08 per mile. What is the least number of miles she would have to travel or drive per year to make leasing no more expensive than purchasing? All right. So this story is saying that a businesswoman wants to either lease a car or buy the car. Lease means borrow a car. Okay. Hire a car, more like hire than borrow. Hire a car that she can use for 1 year or buy the car. So if she hires, then the expenses will be 420 plus 0.06 for each mile. 420 per month plus 0.06. And if she buys, then it will be an annual expense of 4,700 for the whole year plus 0.08 per mile. Okay, so how many miles should she travel so that leasing is no more expensive than purchasing? So our inequality here is leasing should be no more expensive. Okay, cost of leasing cost. All right, leasing should be no more expensive. So leasing cost should be less than, shouldn't be more expensive, but it can be equally expensive. All right, no more expensive means they can be equal, but it shouldn't be more. So leasing cost should be less than or equal to purchasing cost, basically. No more expensive than purchasing. Leasing cost should be less than or equal to purchasing cost. Once I have this inequality, all I can do is just to figure out what the leasing cost is, which the information has been given to me in the question, and then substitute, and then what the purchasing cost will be, and also substitute. But first of all, I need a variable in my inequality. So my variable is usually what is asked. What is the least number of miles? So let X be the least number of miles. Let X be the least number of miles that should be driven so that leasing can be no more expensive than purchasing. All right. What is the least number of miles? So let X be that least number of miles. So that when I eventually solve for X, I have answered the question, the what is question. All right. So let's look at leasing costs now. We are told that she can lease a car for $420 per month. Okay, remember this is cost per an annual cost. All right. $420 per month. And gas for 0.06, all right, for per mile. Okay, so the cost of leasing for 1 year will be 420 times 12, all right, because 420 is for 1 month, plus she will drive X miles in that 1 year. Okay, the cost of gas and oil per mile is 0.06, all right, for each mile that she drives. So for X miles that she will drive for the entire year, the cost will be 0.06x. So all of this forms the total cost of leasing. And this should be less or equal to purchasing. Now, we're told that the annual fixed cost for purchasing is 4,700 plus extra 0.08 per mile. 0.08 for 1 mile. For X miles, it will be 0.08x. So there is my linear inequality in X that I need to solve and get the number of miles for which leasing will be no more than purchasing. So simply do the same thing we always do. Collect like terms. So first of all, my 420 by 12, my 420 times 12 will be 420 times 12 in my calculator. 5040 plus 0.0x is less or equal to 4,700 plus 0.08x. Okay, I would like to bring my 0.06. Let me bring my 0.08 to the side and take my 5040 to that side. All right. So it becomes a 0.06 minus 0.08, okay, which is negative 0.02x. I'm collecting like terms now together, is less or equal to, take 5040 to the side, we get a 4,700 minus 5040, we get negative 340 divide both sides by negative 0.02, negative 0.02, x is greater or equal to, remember we are dividing by a negative number. That's why our inequality sign changes from less to greater. All right, divided by 0.02, we get a 17,000. Okay, so the least number of miles she has to travel is then 17,000. Now notice that it's not 17,001 because this is not a strict inequality. X is greater or equal to 17,000. So X can take the value, it can take values from 17,000 upwards. Okay, 17,002 and so on. The least of them, 17,000. Unlike the case where X is strictly bigger than 17,000, then it can only take values from values bigger than 17,000, which are from 17,001 upwards. Take note of this difference, all right? So our value for X is then equal to X, therefore, X is equal to 17,000. This is the least number of miles that she needs to drive per year for leasing to be no more than purchasing. Okay, that's that for that question. Let's take the fourth one. Okay, the fourth one is number 7, which says a company invests a total of 30,000 of surplus funds at 2 annual rates of interest, 5% and 6.75%. It wishes for an annual yield of no less than 6.5%, right? So this should be 6.5% of its investment, of course. What is the least amount of money that the company must invest at this rate, all right, in order to get its desired annual yield? Okay, in order to get its desired annual yield, what is the least amount of money? So again, our question will be our variable. Let X be the least amount of money, the least amount invested at 6.75%. Let X be the least amount invested at 6.75%. So if X is invested at 6.75%, that tells us that 30,000, because 30,000 is the total amount that these guys want to invest at these two rates. So if they invest X at this rate, then the remaining, which should be 30,000 minus X, is the amount invested, at 5%, of course. All right, so that the sum of these two will give me the 30,000, which is the principal amount invested. All right, so these guys want to have an annual yield of no less than 6.5%. So an annual yield of 6.5 or more, basically greater than or equal to 6.5%. So the yield, so we invest, so for the investment at 5%, it yields 30,000 minus X times 5% plus the investment at 6.75% should be X times, let me put it the other way around, should be 0.0675 times X, and the sum of these yields should be no less than, so that's to say it should be greater than or equal to 6.5% of 30,000, basically 0.065 of 30,000 of their total investment. Okay, again, we have this linear inequality in X to solve for X. These are our applications. Okay, so we open up our brackets, 0.05 by 30,000 times 0.05 is 1,500 minus 0.05x plus 0.0675 x should be greater or equal to 30,000 times 0.065, which is 1,950. Okay, collect like terms together as usual. We add up these two terms in X. We get 0.05 plus 0.0675, which is 0.1175. 1,500 minus 0.1175x is greater or equal to 1,950. Move the 1,5 to that side, right? No, we didn't add this nicely. It's supposed to be negative 0.05x plus that guy. We always read every term together with its sign, all right? So it's typically 0.0675 minus 0.05, basically 0.0175. This is very important. I'm happy I made this mistake just to show you how important it is to always read a term together with its sign, the way I specified and emphasized in our previous videos, all right? This is not, so the mistake I made was to add 0.05 and 0.0675, and I got the wrong answer. Okay, and this is a mistake, common mistake most of you will make. Instead of adding negative 0.05 and 0.0675. Okay, so the right answer will be positive 0.0175. Move my 1,5 to that side. I get 0.0175x is greater or equal to 1,450, basically. Okay, if we subtract 1,5 from 1,950, we should get 450. Okay, divide both sides now by 0.0175, 0.0175. Then we get our x to be greater or equal to 450 minus 0.0175. We get x to be greater or equal to, so I'm rounding to the, okay, 499.98, basically, all right? X is greater or equal to this. So the least amount that should be invested, are we not missing something? Okay, I think I'm missing something. I should be dividing, not actually made a mistake and subtracted on my calculator instead of dividing. Okay, it's really absurd that the amount is this small from 30,000. So it's actually 450 divided by, not minus, 0.0175. Okay, so the answer is 25,000. So x should be greater or equal to 25,714.29. Okay. Okay, so the least amount is this amount, 25,714.29. That's the least amount that should be invested at the rate of 6.75%, in order for us to realize a 6.5% profit. Okay, hope that's clear. Let's look at the last one. The last one says, it says the current ratio of precision machine products is 3.8. If the firm's current assets are 570,000, what are its current liabilities? Okay, so we know that current ratio is given by current assets over current liabilities. Okay, the formula for current ratio is current assets over current liabilities. Okay, so we can just substitute everything in there and get our answer basically. So this is just giving us an equation per se, not an inequality. So the inequalities are applicable in the second part where we need to raise additional funds. So current ratio is given by 3.8 is equal to current assets 570,000, and we are looking for current liabilities. Okay, so basically CL, if we were to make it the subject of formula in this equation, CL will just be 570,000 divided by 3.8. Okay, which is 570,000 over 3.8, which is 150,000. Those are the current liabilities for that business. Okay, so that's that. You can look at the few more that I left out for the sake of the length of this video, and we will see more of it also in class. Thank you.